All right, today we're going a little bit deeper into surface area and volume of prisms. So first, I'm just reminding you of how to go forwards and backwards from exponential to radical form. So here I'm saying simplify each radical or rational expression. So in exponential form, we have x to the 1/2 power. So if I put that in radical form, here is my radical, just like so. The x goes underneath it. Here is the index of 2. Here is the exponent of 1. So here where that bottom is, right there, that tells us the index, what kind of root we're taking, and then the numerator tells us the exponent. Now, in this variation, we don't usually write the 2. We don't usually write the 1. If something's raised to the first power, it's just itself. And when it's a square root of 2, we usually just write it with the radical. It's implied that it's a square root. So, just to clarify, this is how I would write the square root of x. I wouldn't write the 2, I wouldn't write the 1. Right now, I'm writing that just to show you the position. So if I have x to the 1/3 power, here, this is like saying the cube root of x to the first power, but really we just write that as the cube root of x. So if it's a square root, we do not write the index. If it's anything else, we do. So then lastly here, if I have x to the a over b power, the a is the exponent, the b is the index. So here I would be saying the square root, or not square root, right? Not necessarily. The b root here, b root of x, and then raised to the a power just like that. So that would be fully simplified. All right, so for a, I'm looking at the square root of 80. It has to be a square root because there is no index marked. So it is implied that it is a square root. So here I just need to break it down. And we've had a lot of practice with this school year. So if I look at 80, I know that that is 16 times 5. And then 16 is a perfect square. It gives me that pair of 4s with that 5 that stays behind. So on the outside, I have the 4. And then underneath the radical, I have the 5. So this reads as 4 times the square root of 5. Okay, now I'm looking at a cube root, so cube root of 27. Now that index is telling me that I'm looking for 3 of the same. So if I think about what multiplies to 27, I know that that's 3 times 9, and then the 9 is 3 times 3. So here I'm going to swoop up my 3 of the same. I know that 3 to the 3rd power would be 27. So every group of 3 of the same, I'm going to circle them as a group and pull them out from underneath the radical. So here this would simplify to be just 3. Okay, next here I have a cube root of 256. So again, my index is 3. I'm looking for 3 of the same. So maybe I see that this is 4 times 64. And then the 64 is going to be 4 times 16. And the 16 gives me 4 times 4. So I can see, okay, here are my 3 4s. And then here's this 4 that stays behind, right? There's only going to be 2 2s that would multiply to that 4. So there's no group of 3 to pull it to the outside. So I'm going to write my answer as 4 because here are 3 of the same, 4 on the outside. Underneath, here's that 4 that stays behind. And what's absolutely crucial here is that I have to make sure that I write that index. Otherwise, it reads as a square root and not a cube root, which would produce an entirely different answer. So this is 4 times the cube root of 4. That is my answer. Okay, over here I have the 4th root. So I'm looking for 4 of the same thing, the 4th root of 64. So here if I break it down, I can see, oh, well, that's 2 and 32. 2 and 16, 2 and 8, 2 and 4, 2 and 2. So again, I'm looking for 4 of the same thing because it's a fourth root. It's not a square root. It's not a cube root. It's a fourth root. So here are 4 of the same. And I see that here are 2 2's, but I don't have a group of 4 to multiply to be able to pull it out. So I'm going to have to multiply that back underneath the radical. So on the outside, here are the 4 of the same. So I have a 2 on the outside. Underneath, I have to multiply that 2 and 2 right here back. I can't forget my index, otherwise it reads as a square root. So there's my index of 4. And then finally, it's going to be 2 times the fourth root of 4. Those 2 2's had to multiply back underneath the radical because there was not a group of 4 of the same to be able to pull them out. Okay, next up here I have 64, and it's raised to the 2/3 power. So if I write that in radical form, that is like saying 64 is underneath the radical. I'm looking at a cube root of 64, and then I'm going to square it. So cube root of 64, well, 64 is 4 times 16, and then 4 times 4. Here's my 3 of the same. So the cube root of 64 is 4. And then I have to square it, and that gets me to 16 overall. Okay, for F, here I have 64 to the negative 3/2 power. So again, underneath my radical is the 64. My index is 2. Okay, I don't usually write the 2. I'm just writing it there just to remind you of the position. And then raised to the negative 3rd power. So the square root of 64, we all know that's 8. 8 to the negative 3rd power. Well, that's like saying 1 over 8 to the positive 3rd power, which then becomes 1 over 512. All right, so starting today with a little bit of a radical rational review. Okay, so here we go. Find the area of a circle with a circumference of 18 pi feet. So we're finding the area, we know the circumference. So I would start by just stating what the circumference is. So the circumference is 18 pi. We know that the circumference is 2 pi r. Okay, my area, I know that that's pi r squared. So I can see that what the formulas share in common is the radius. So I need to figure out, well, what's the radius of my circle? So if I know that my circumference is 18 pi, and that's, the formula is 2 pi r, I can set 2 pi r equal to 18 pi. And then I can divide each side by 2 pi, and I get a radius of 9. So when I plug that in for my area, if I plug in that 9, pi times 9 squared is going to get me 81 pi. And we're talking about area, so we always say square feet. Okay, find the circumference of a circle when we know its area is 40 pi square feet. So I'm going to do the same thing, right? I know that my area, right, we're told that it's 40 pi. I know its formula is pi r squared, but we want our circumference this time, which is 2 pi r. So I have both of my formulas laid out. I know that the key is finding the radius. So if I know that the area is 40 pi and the formula is pi r squared, I can set the pi r squared equal to the 40 pi. So now I can divide away the pi from each side. The radius squared equals 40. I can solve by taking the square root. Okay, I know that 40 is 4 times 10, so I know that my radius could be plus or minus 2 root 10, but we know that a radius has to be positive, so it has to be the positive 2 root 10. So if I plug that in here, 2 root 10 is going in for the radius. So I'm taking the 2, multiplying it by the pi, multiplying it by the 2, multiplying it by the root 10. So when I organize this, I'm going to multiply the 2 times the 2 and get 4. I'm going to put the pi next, and then the root 10 last. So the reason that I'm having you write it like this is just so that there's no confusion as to where the pi is. If we attach it at the end, sometimes we interpret that as underneath the square root, and I just want to make sure that we're very clear that it is not underneath the square root. It is outside of it. So it's 4 times pi times the square root of 10. And we're just saying that our units are feet. All right, so just going forwards and backwards, did I start you with circumference and we got to area, or vice versa? Okay, please flip to the second page. Okay, so here's some prism problems that are just word-based. And first, we're just starting with a little review of just triangles. So the legs of an isosceles triangle are 8 feet with a base of 4 feet. Find its area. So always helps to visualize. So I'm looking at an isosceles triangle. So let me draw an isosceles triangle. 2 sides are the same. So the legs, the 2 sides that are the same, both 8 with a base of 4. So what's so nice about an isosceles triangle is that we can always split it right down the middle and make 2 perfectly congruent right triangles. So I'm going to go ahead and split it right down the middle just like so, which means that right here is 2 and this is 2. To find its area, I need to figure out the height of it. I need to know what this measure is right here. So I have to visualize this right triangle first, where this is my height, this leg is 2, and the hypotenuse is 8. So I'm using a little Pythagorean theorem to get me there. So h squared plus 2 squared equals 8 squared. So my height squared plus 4 is going to equal 64. Take away the 4 from each side. The height squared is equal to 60. Take the square root of each side. We know that 60 is 4 times 15. So I'm going to get plus or minus 2 root 15. And of course, it has to be the positive. So the height is 2 root 15. So that was the part that I needed, that height of 2 root 15. So now that I have it, I can find the area. My area of a triangle is 1/2 the base times the height. So I'm saying 1/2. The base is 4, and the height is 2 root 15. So if I multiply across, half of 4 is 2. 2 times 2 back to 4. So I get 4 square root 15 square feet. Okay, next, returning to a 30, 60, 90 triangle, and I'm saying that the longer leg is 10 feet. So if I sketch out a 30, 60, 90 triangle, here would be my 30-degree angle, here would be my 60. So my short leg is opposite my smallest angle. So my short leg right here is my x. My longer leg is opposite my middle angle. So opposite the 60 degrees is my x root 3. Okay, and then my hypotenuse is opposite the largest angle, the 90-degree angle, that's the 2x. So here I'm telling you that the longer leg is 10. So to get to x, I need to take 1/3 of 10 and multiply by the square root of 3. So I'm going to get 10 root 3 divided by 3 for my short leg for x. And then I can multiply that by 2 to get the hypotenuse. So I get 20 root 3 over 3 for the hypotenuse. Just to remind you of how we can get there without knowing that shortcut, I could have also just said x root 3 is equal to 10. And then I can divide each side by the square root of 3. And then when I rationalize the denominator, so get that square root of 3 out of the bottom, I can always multiply by 1 and preserve the ratio. Anything over itself is 1. So here I'm confirming that 10 root 3 over 3 figure that I had right here. So I know that when I know this side, when I know the longer leg, the x root 3 side, I can see that what the work is doing, it's dividing by 3, right, which is the same as multiplying by 1/3, and then here multiplying by the square root of 3. So I just took 1/3 of the 10 and multiplied by root 3, and it got me there faster because of the mechanics up in here. All right, so now area. Area, it's a triangle, so 1/2 base times height. And when it's a right triangle, my legs are my base and my height. So I'm taking 1/2 times 10 root 3 over 3 times 10. I'm just going to write that as a fraction, so I'm going to write it over 1 just to see things really clearly. So if I want to simplify, I can always reduce top to bottom. So here what I can see is that this 10, for example, and this 2 can reduce to 5 and 1 because they were both divisible by 2. There's nothing else that I can reduce. So I'm going to multiply straight across. 5 times 10 is 50. So I have 50 root 3 divided by 3. So my answer will be 50 root 3 divided by 3 square feet. If you left that as a mixed fraction, that would be fine as well. All right, for 6, a cube has a volume of 512 square feet. Find its surface area. Okay, so I know that my volume for a cube is going to be a side cubed. So I'm just going to call my side x. So volume is x cubed. Okay, and I'm given that the volume is 512. Okay, I'm going to want the surface area, and I know that my surface area for a cube, I have 6 perfect squares. So my surface area will be 6 times x squared. So again, I'm just defining x as my side. Okay, so then the key is really I need to figure out what a side measure is so that I can find my surface area. So if I know that volume is a side cubed and volume is 512, well, I can say that a side cubed is equal to 512. So now to solve, to unlock that cube, I have to take the cube root of each side, which is why we practiced that skill earlier in our lecture. So if I'm looking for the cube root of 512, well, 512 is 8 times 64, and then here 8 times 8. Here are my 3 of the same, which I'm required for a cube root. So I know that my side length is 8. So x is 8, a side length is 8. So now when I go over here, I'm plugging in an 8 for my side length. So I have 6 squares. Each one has an area of 8 squared. So I'm taking 6 times 64, and I get 384 square feet. So a cube that had a volume of 512 cubic feet will have a surface area of 384 square feet. So remember that surface area is the number of non-overlapping unit squares that cover a figure, just like wrapping paper. And we know that volume is the number of non-overlapping unit cubes that fill up a figure, just like the water in a fish tank. All right, next up. A cube has a surface area of 294 square feet. Find its volume. So it's very similar skill, it's just having us go in the opposite direction. So here we're starting with surface area. So surface area, we know that it's 6 perfect squares. So 6 times x squared. I'm defining x as a side again. Let me make sure that that is clear. Okay, and then I know that my surface area is 294. Okay, I want volume. Volume is a side cubed. So I need to figure out what's my side. So I know that 6x squared equals 294. To get to x, I need to first divide each side by 6. So x squared equals 49. And now to unlock that square, I can take the square root of each side. I know that technically that gives me plus or minus 7, but I'm only interested in the positive. So my side length has to be 7, and that's what I'm plugging in right here. So 7 to the third power, 7 times 7 times 7, gets me 343 square feet. No, not square, cubic feet, it's volume. So surface area will always be units squared, volume will always be units cubed. All right, next up, find the height of a right regular hexagonal prism with a base perimeter of 72 feet and a volume of 1,728 times the square root of 3 cubic feet. Okay, so it helps if you can visualize it. So here, just to help you visualize it, here is a hexagonal prism, a right regular hexagonal prism. So my 2 bases are perfect regular hexagons, and I know that all of my lateral faces, they are rectangles. Okay, so let's kind of take stock of what we know. We are given in the problem, we're given the volume. Volume is the base area times the height. And we're told that volume is 1,728 times the square root of 3 cubic feet. Okay, so we know what volume is. We know what our base perimeter is. And we're trying to find the height. So we know how to find our base area if we know the perimeter. So I'm going to write a little note. Find the base area first. Okay, so if I draw out my base shape, it's a regular hexagon. Okay, we know that the perimeter is 72 feet. So if I want to know each side, I take that 72, split it 6 ways, and I get 12. So each side is 12. So here, I know then that I can draw in the apothem and a radius. So right here would be my 60-degree angle, and here is my 30. Here is x, here is x root 3, here would be the 2x. So I know that right here would be 6 and 6 root 3 for my apothem. So for my base area, 1/2 the apothem times the perimeter, I'm plugging in my apothem of 6 root 3 and my perimeter of 72. So if I take 1/2 of 6, that's 3, times 72, I get 216 root 3 square feet. So I actually now know my volume, I know my base area, I can solve for my height. So let me go back to the equation. Volume equals base area times height. And just plug in what I know. 1,728 times the square root of 3 is equal to 216 times the square root of 3 times the height. So now all I have to do is divide each side of my equation by 216 times the square root of 3. So over here, that knocks all the way away to 1 to 1. Over here, the root 3's knock away 1 to 1. So really, I just need 1,728 divided by 216, and I end up with a nice clean integer value of 8. My height is 8 feet. Okay, one more problem. So here, find the surface area and the volume of a right triangular prism whose base is a isosceles right triangle, with a hypotenuse of 8 feet. The prism has a height of 6 feet. Okay, so maybe we draw it out this time. So if I'm drawing my base shape first, it's an isosceles right triangle. So let's start with that. Here is an isosceles right triangle. It's a 45, 45, 90 triangle. So there's my base. Okay, I'm going to replicate the base on the bottom. So here, background and foreground, just like that. And then I'm just going to connect here all of these lateral edges to make it go in 3 dimensions. So I drew the top base, I drew the bottom base, and then I connected those segments so I can try to picture this as foreground, background. Okay, we're told that the base is an isosceles right triangle, the hypotenuse is 8 feet. So right here is 8 feet. The prism has a height of 6 feet. So here is the 6 feet for the prism itself. So I know first I got to focus on my base shape. So if I sketch out my base shape, it's an isosceles right triangle where the hypotenuse is 8. These angles would have to be 45 degrees. So I know that the two legs, x and x, the hypotenuse is x root 2. So if I take half of 8 and multiply by root 2, I'm going to get 4 root 2 and 4 root 2 for my two legs. So now if I get my area, my base area first, I know that that is 1/2 base times height. And when it's a right triangle, my legs are the base and the height. So I'm doing 1/2 of 4 root 2 times 4 root 2. That's like saying half of 4 times 4 times 2. So I get 16 square feet for each base. So the top base is 16 square feet, the bottom base is 16 square feet as well. So for surface area next, I know that I'm looking at the lateral area, so height of the prism times the perimeter of its base, and then I have to add those two base areas. Volume will be just base area times height. So surface area first. Height of the prism is 6. Perimeter of the base, right, if I add up all these sides, I can only add my like terms. So I have 8 plus 8 root 2. And then I have two bases. Each one has an area of 16. So now I have to distribute the 6. So I get 48 plus 48 times the square root of 2. And then add the two 16s, which is 32. I can only combine the 48 and the 32, so I get 80 plus 48 root 2, and then square feet. Okay, volume, my base area, already solved for it, 16 times the height of 6. So I get 96 square, not square, keep wanting to say square, cubic feet. Okay, surface area, are units squared, volume, units cubed. All right, that's all I have for us today. I hope you guys are doing well. I hope to see you soon.